Hello everyone, my name is Corentin Meyer, third year PhD student in bioinformatics in Strasbourg, and today I'm going to present you my work that is called Method for the Exploitation of Multimodal Patient Data using Artificial Intelligence with an application to congenital myopathies. So the main objective of my work is to develop AI tools that are able to exploit unstructured text and images coming from patient data. So, to begin with, patient data and biomedical data in general are unstructured multimodal big data. So it means that you have a lot of them, but most of the data are multimodal, so you can have text, images, sequences, and are unstructured, meaning that they have all different kind of form and shape, and most of the time are not very well annotated. And so because you have so much data, most of the time you want to use AI techniques to analyze them and to explore those data. But the issue is that machine learning is not very well suited for biomedical data because it's only good for tabular, well-annotated data, which is not the case here. But over the last decades, we have seen the strong development in artificial intelligence of deep neural networks. And deep neural networks are able to exploit all kinds of data, including image, text, sequences, videos, audios, and anything like this. And it doesn't require your data to be well structured. It can be of all shape. And we are interested into congenital myopathies. And congenital myopathies are a family of genetic and rare disease whose diagnosis is very challenging. And because up to today, we still have 50% of the patients that are not well diagnosed for the congenital myopathy subtypes they have. But the main diagnosis criteria for those diseases are the muscle biopsy images and the medical text reports that list all the observations that are made on the clinical side and also on the histological side. So to exploit those biomedical patient data, we developed two tools that are able to exploit on one hand the medical text reports and on the other hand the image data coming from those muscle biopsies. So the first tool that I'm going to present to you today is NLMyo, which stands for Natural Language Myopathy, which is a tool that I developed that uses large language models to exploit medical text reports. So this tool is available online, has a demo version of the link that is provided, but also its source code is open source. So let's say, for example, that you have a PDF text report from a patient that lists the patient, his name, his age, and several observations. You are going to want to have tools that are able to exploit those data without too much manual work. So we use two types of large language model to develop four tools in total. So the first types of large language model are generative models that we use are such as ChatGPT with custom prompts. And using those generative models, we develop two tools to exploit those data. And the first one is an anonymization tool that is able to take your PDF input and to remove any personal information about the patient inside your PDF. So basically what you get is that all the names such as the medical staff name or the patient name and his birthday are removed from your data, are blacked out from your PDF. And this is very flexible because it works with any kind of text. It doesn't require a specific structure. And once you have your anonymized PDF, you can use Meyer extracts that is able to extract common information from your text. So basically it's about taking your text as an input and creating a nice table. For example, with the biopsy number, the age of the patient, the muscle that is been taken, the diagnosis, and the anomalies that have been found. And so this is automatical with a custom prompts. So it can annotate the data for you and create a nice table with all your PDF patient. And the second model that we use are embedding models, which turns text into big numeric vectors and that retains the semantic meaning of your text. And this allows us to create two tools. The first one is myoclassify that is able to predict the diagnosis of the patient based on the raw text inputs, so without any annotation. And so basically what we do is that we embed the texts and then we train a random forest or a perceptron, which are basic machine learning algorithm, to predict the diagnosis. And for example, on 140 patient reports, we obtained a 70% accuracy over 4 myopathy diagnoses. The second tool that we created using embedding models are Meyer Search, which is an automatic search engine that is able to be queried with symptoms, and that will automatically show you, based on similarity score between your query and the patient report in the database, the patient that have your symptom of interest. So you can quickly create a search engine based on your data and query it. The second tool that we developed for this data is myQuant, which is an AI tool to quantify pathological features in muscle histology images. So it's also available online as a demo version, but also as a command line tool that is able to quantify whole slide image made of thousands of fibers, muscle fibers, in few minutes. So we have three quantification methods that are implemented yet. The first one is intensity-based method that's based on the intensity of each fibers, classify them and set automatic thresholds. The second one is the analysis of the nuclei position that calculates a centralization score for all the nuclei in each of your muscle fibers and can classify them into centralized or peripheral nuclei. And the third one is a custom AI that we train to detect mitochondria anomalies. So it's trained on 17,000 fibers that we classified by hand between fibers with mitochondria anomalies and fibers that are healthy. And we obtained a 94% accuracy on the classification of those fibers. So to finish with those tools that I've presented today, so NL, and myQuant are free and open source tools that we've created to exploit text and image data coming from patients using cutting-edge AI. Feel free to scan the QR code on the left to find all this work that I've presented to you today, or to contact me using my website or my emails. Thank you very much for your attention.